You are welcome to another lesson on new focused approach to mathematics basics 7 revised edition. And in this video, we want to look at how we can find highest common factor, that is HCF, and least common multiple, or the lowest common multiple, that is LCM, of set of numbers. And we are going to apply the principle of prime factors. And I'm sure you know how to find prime factors of a number. Remember, we know from our previous lesson that prime number simply means any number that has only two factors. Like 2 will give you factors as 1 and 2. 3 has 1 and 3. 5 has 1 and 5. If I pick 6, this is not a prime number because 6 will give you 1, 2, 3, and 6, which is more than 2 factors. So 6 is not a prime number. Right. Now, let's revise our knowledge on how to find the prime factors of a number. For example, having 60, okay, how do we find prime factors of 60? What we are trying to do is that we need to get divisors that will be prime number. We can choose to do from the beginning using any number to divide, that is if the number can divide 60. Okay, so let's see if I say 2 can divide 60 easily as 30. And again, I can pick a prime number that can divide 30 and it will still be 2. Or I can even pick 3 straight away and say 3 times 10. Or 2 will divide this as 15. Now, what other prime number can divide 15? That will be 2. 2 divide 15 as, 3. 3 divide 15 as 5. And so we can see that the numbers we have left, that is 3 and 5, there is no number that can divide apart from 1 and itself. And so we end it there. So our prime factors from our previous knowledge will be 2 squared times 3 times 5. This is what we learned on how to find prime factors of a number. Let's take 36. Okay, 36, I can pick any number that can divide 36. I can start with 3. I can start with 2. But if I feel like starting with 6 times 6, which I know 6 times 6 will give us 36, it's fine. But then the 6 here is not a prime number, so I have to divide again. 2 can divide 6 as 3, fine. And 2 can also divide here 2 as 3. So again, we have 2 squared times 3 squared. These are the prime factors of 36. Now, how do we leverage on this idea to find the highest common factor and the lowest common factor of two numbers? Okay, so let's start with 48. 48, when we go through the same process we went through, I can say 2, 24, 2, 12, 2, 6, then 2, 3. Together, I'm going to write 2 exponent 4 times 3. Then with our 60, we learned the 60 from the previous one that we did. That is 60 gave us 2 exponent 2, 3, and 5. So 2 exponent 2 times 3 times 5. This is the answer we had for 60. Now, how do we then find highest common factor of this? To find the highest common factor, we need to first ask ourselves, among these numbers, which of them are common to both sides? We can see 2 is common, and we can also see 3 is common. So when we pick the 2 and 3 that are common, with the 2, we have the exponent of 4 and exponent of 2. The least exponent is 2, so we put 2 here. We can't take 5 because 5 is not common to both sides. So we just multiply this, and that becomes our highest common factor. And that will give us 4 times 3, which is 12. So the highest common factor for 48 and 60 is 12. What it means is that 12 is a factor of 48 and 12 is a factor of 60. We have other factors, but then the highest of it will be 12. Right. Then let's do another example. Let's say we want to find, before then, let's do the least common multiple. That is the LCM of these same two numbers. Again, we utilize the answer that we have here That is this and that. In this case, because you're using LCM, we pick the unique prime factors. And the unique prime factors, among them, we have 2 is unique, we have 3 is also unique, then we have 5 also is unique. So these are the 3 that are unique. Okay, then what we do is that the one that appear, or maybe after picking the unique ones, we pick the highest degree. Okay, so for the 2, we have 2 here, 2 here, so the highest degree is 4. We have 3 here, 3 here, the highest degree still remain 1, so we keep the 1. We have 5, the highest degree is 1. So when we multiply all this together, we have 16 times 3 times 5. And 16 times 3 times 5 will give us 240. So that is how we can use the prime factors to find the LCM. That means if you want to find the lowest common multiple of 60 and 48, you use 240. All right, let's do another example and see. Here we have 54 and we have 72. Now take your time and then generate the prime factors of 54 separately, okay, and do the same thing for 72 separately. Let's see the result. I'm sure you can pause the video and try this. I'm sure you are done with this and your answer came as, for 54 we have 2 exponent 1 times 3 exponent 3, and then for 72 I'm sure you had 2 exponent 3 times 3 exponent 2. Now let's use it to find the highest common factor, which is the HCF. Again, we look at the common numbers or the common prime numbers that are common to both numbers. 2 is common there, and then 3 also is common. Now with the 2, among the 2 we have power 1 here, and we have that is the exponent 1 and exponent 3. The lowest is exponent 1, so we pick the exponent 1. Then among this and then that, the lowest is 2, so we pick this one. Then we multiply. 3 times 3 is 9 times 2, which is 18. So here the highest common factor is 18. That means 18 is a common factor of 54, and 72 is a factor of 18 is a factor of 72. So the common among them will be 18, which is the highest. Then to find the LCM, okay, that one too, we look at the uniqueness of the numbers involved, and we have 2 involved, we have 3 involved, we don't have any other number again, so we keep the 2 and 3. Then here with the 2 we pick the highest degree or highest exponent, which is 3, so I'm going to have 3 here. Then among the 3 and then the 3 here too, we pick the highest, which is also 3. So we are going to have 2 times 2 times 2, which will give me 8. Then 3 times 3 times 3 also give us 27. Now, when we multiply this together, we have 216, and that becomes the answer. So the least common multiple of 54 and 72 is 216. Beautiful. I'm sure you've gotten the concept clear. Okay, let's try the last example, then we can go ahead and solve more questions in your book. Now, we want to find HCF and LCM of 21 and 28. Again, you can try generating the prime factors of 21 yourself, and then you can do the same thing for 28 yourself as well. Now for 21, we know you're going to just get 3 times 7. Then for 28, you get 2 exponent 2 times 7 as well. Now to find the HCF, we said we look at the common numbers that appear in both prime factors. 3 is here, 3 is not here, so we can't pick 3. 2 is here, 2 is not here, so we can't pick 2, but 7 is common among them, so we pick 7. And then we look at 7, the exponents are all the same, 1, 1, so our answer becomes 7. That means the highest common factor of 21 and 28 is 7. Now the least common multiple of these two numbers, 28 and that, Again, here we only just have to pick the uniqueness of all the prime numbers you use. We have 2 among it, we have 3, and then we have 7. Here we don't care about what is common, we care about the unique prime numbers that are found here. Then each of the numbers, we pick the highest exponent. So for the 2, the highest is still 2. For the 3, the highest will still be 1, and then the 7 is 1. Then we multiply all of this. So we have 4 times 3 times 7. And when we multiply them together, 4 times 3 is 12. 12 times 7 is 84. So that becomes the LCM. So with this, we come to the end of this lesson on how to find highest common factor and least common multiple of numbers. Thanks so much for choosing focused approach to mathematics.